Welcome to Keen's on Science. This is a series of SLOP questions aimed at calculating relative formula mass as part of your GCSE revision. The aim is that you get shed loads of practice on calculating relative formula mass. Let's dive straight in. Question 1 says calculate the relative formula mass of water. We're given the formula, which is H2O, and the first thing we've got to do therefore is calculate the mass of hydrogen. So we see from the formula that we've got 2 molecules of hydrogen, so hydrogen is 1 times 2 is 2. Oxygen, we've got 1 molecule of oxygen, the mass of oxygen is 16, so 1 times 16 is 16. We've then got to calculate the total mass, which is just a matter of adding those two numbers together. 16 plus 2 is 18. So relative formula mass of water is 18. Question 2 says calculate the relative formula mass of carbon dioxide. We're given the formula CO2. The first thing we've got to do is calculate the mass of carbon. So we can see from the formula we've got 1 atom of carbon. Carbon's atomic mass is 12, so 1 times 12 is 12. Oxygen, we need to calculate the mass of oxygen. So we can see from the formula we've got 2 atoms of oxygen. So oxygen's got an atomic mass of 16, so 16 times 2 is 32. We can then calculate the total mass. 12 plus 32 is 44. The relative formula mass of carbon dioxide is 44. Question 3 says calculate the relative formula mass of hydrochloric acid. We're given the formula, which is HCl. The first thing we've got to do is calculate the mass of hydrogen. We can see from the formula that we've got 1 atom of hydrogen, so 1 times 1 equals 1. We've then got to calculate the mass of chlorine. Again, from the formula, we can see we've got 1 chlorine. The mass of chlorine is 35.5, so we've got 1 times 35.5. We then calculate the total mass, so 1 plus 35.5 is a total of 36.5. So the relative formula mass of hydrochloric acid is 36.5. Question 4 says calculate the relative formula mass of copper oxide. So again, we're given the formula CuO. We've got to first of all calculate the mass of copper. We can see from the formula we've got 1 atom of copper. Copper weighs 63.5, so we've got 1 times 63.5. Oxygen, we can see from the formula we've got 1 atom of oxygen. Oxygen weighs 16, so 1 times 16 is 16. We've therefore got to calculate the total mass, so it's 63.5 plus 16, giving us a total of 79.5. So the relative atomic mass of copper oxide is 79.5. Question 5 says calculate the relative formula mass of copper oxide. Again, we're given the equation CuCl2. First thing we've got to do is calculate the mass of copper. From the equation, we can see we've got 1 atom of copper. Copper weighs 63.5, so it's 1 times 63.5. Chlorine, we've got from the formula 2 atoms of chlorine. The mass of chlorine is 35.5, so 2 times 35.5 is 71. We've then got to calculate the total mass, so it's 63.5 plus 71 equals 134.5. So the relative formula mass of copper chloride is 134.5. Question 6 says calculate the relative formula mass of aluminium chloride. We've got the formula AlCl3. We've got to first of all calculate the mass of aluminium. So from the formula, we've got 1 atom of aluminium. Aluminium weighs 27, so 27 times 1 equals 27. Then we've got chlorine. So from the formula, we've got 3 atoms of chlorine. So the relative atomic mass of chlorine is 35.5 multiplied by 3 is 106.5. We've then got to calculate the total mass. 27 plus 106.5 equals 133.5. So the relative formula mass of aluminium chloride is 133.5. 7 says calculate the relative formula mass of carbon monoxide. We're given the formula CO. The first thing we've got to do is calculate the mass of carbon. So from the formula you can see we've got 1 atom of carbon. Carbon's got an atomic mass of 12, so in total carbon is 12. Oxygen, from the formula you can see we've got 1 atom of oxygen. Oxygen's got atomic mass of 16, so in total 16. So we work out the total mass for the compound. 12 plus 16 is 24. So the relative formula mass for carbon monoxide is 28. Question 8. Calculate the relative formula mass of magnesium oxide. Formula MgO. So first thing I've got to do is work out the mass of magnesium. So I've got one atom from the formula of magnesium. Magnesium's got atomic mass of 24. So in total 24 for magnesium. Oxygen from the formula, we've got one atom of oxygen. Oxygen's got atomic mass of 16, so in total 16. So the calculate the total mass of the compound is 24 plus 16, which is 40. So the relative formula mass of magnesium oxide is 40. Question 9 says calculate the relative formula mass of sodium chloride, NaCl. So first of all, calculate the mass of sodium. Sodium has got a mass of 23, so 1 times 23 is 23. Chlorine, we can see we've got one atom of chlorine. Chlorine's got a mass of 35.5, so the total mass is 23 plus 35.5, so it's 58.5. The relative formula mass for sodium chloride is 58.5. Then says calculate the relative formula mass of hydrogen peroxide. We're given the formula H2O2. So first thing we've got to do is calculate the mass of hydrogen. Hydrogen has got a mass of 1, and we can see from the formula we've got 2 atoms. So in total, it's 1 times 2 is 2 for hydrogen. Oxygen, from the formula, we have got 2 atoms. Atomic mass of oxygen is 16. So the mass of oxygen is 2 times 16, which is 32. We then calculate the total mass. So the total mass is 32 plus 2, which equals 34. So the relative formula mass of hydrogen peroxide is 34. 11 says calculate the relative formula mass of aluminium oxide. The formula is Al2O3. So the first thing we've got to do is calculate the mass of aluminium. We know from the formula we've got 2 atoms of aluminium. Aluminium's got an atomic mass of 27, so 2 times 27 is 54. Oxygen, calculate the mass of oxygen. We've got 3 atoms of oxygen from the formula. Oxygen's got atomic mass of 16, so 3 times 16 is 48. We then calculate the total mass, so 54 plus 48 equals 102. The relative formula mass for aluminium oxide is 102. Question 12 says calculate the relative formula mass of potassium chloride. We're given the formula KCl. So the first thing we do is work out the mass of potassium. Potassium has got a mass of 39, and we've got one atom, so in total 39. Chlorine has got atomic mass of 35.5, and from the formula we've got one atom of chlorine, so total mass of chlorine is 35.5. We then calculate the total mass, so 39 plus 35.5 gives a total of 74.5. So the relative formula mass of potassium chloride is 74.5. 13 says calculate the relative formula mass of lead nitrate. We're given the formula Pb brackets NO3 outside brackets 2. So first thing we've got to do is calculate the mass of lead. So from the formula we can see there's no number next to the Pb, so we've only got one atom. So the atomic mass of lead is 207, so in total we've got 207 for lead. For nitrogen, we've got to work out the mass of nitrogen. So nitrogen is inside a bracket with no number next to it, but a 2 outside the bracket. So this 2 means that there's 2 lots of everything inside the bracket. So we've got 2 atoms of nitrogen. Nitrogen's got atomic mass of 14, so in total that's 28 for nitrogen. We've then got to work out the mass of oxygen. So for oxygen, there's 3 atoms inside the bracket, but 2 outside the bracket. So 3 times 2 is 6, so in total we've got 6 atoms of oxygen, each with atomic mass of 16. So our total atomic mass for oxygen is 96. We then calculate the total mass, so 207 plus 28 plus 96 gives a total of 331 for the relative formula mass for lead nitrate. Question 15 says calculate the relative formula mass of potassium nitrate. We're given the formula KNO3. First thing we've got to do is calculate the mass of potassium. So from the formula we've got one atom of potassium, atomic mass is 39. So 39 times 1 equals 39. We've then got to calculate the mass of nitrogen. So we've got 1 atom of nitrogen from the formula. Nitrogen's got atomic mass of 14. So 14 times 1 is 14. Oxygen, calculate the mass of oxygen. We can see from the formula there's 3 atoms of oxygen. Oxygen's got atomic mass of 16. So 16 times 3 is 48. We then calculate the total mass. 39 plus 14 plus 48 equals a total of 101. The relative formula mass of potassium nitrate is 101. Question 15 says calculate the relative formula mass of sulfuric acid, H2SO4. So the first thing we've got to do is calculate the mass of hydrogen. From the formula, we've got 2 atoms of hydrogen. Hydrogen's got atomic mass of 1, so in total for hydrogen is 2. Sulfur, we've got 1 atom of sulfur. Sulfur's got atomic mass of 32, so in total 32. And oxygen's got atomic mass of 16, and we've got 4 atoms of oxygen from the formula, so in total 64. So total mass is 2 plus 32 plus 64, so total mass of sulfuric acid is 98. Question 16 says calculate the relative formula mass of potassium sulfate. We're given the formula K2SO4. So first we've got to do is work out the mass of potassium. So we've got 2 atoms of potassium. Potassium's got atomic mass of 39. So 39 times 2 is a total of 78. Sulfur, from the formula, we can see we've got 1 atom. So sulfur has got a mass of 32. So in total 32 for sulfur. And then oxygen, from the formula, we can see we've got 4 atoms of oxygen, each with atomic mass of 16. So oxygen is 4 times 16, so a total of 64. So we then calculate the total mass of the compound, which comes out at 174. So the relative formula mass of potassium sulfate is 174. Question 17 says calculate the relative formula mass of aluminium hydroxide, Al brackets OH close brackets 3. So first of all, we've got to calculate the mass of aluminium. So from the formula, we can see aluminium, there's 1 atom, a mass of 27. So in total for aluminium, it's 27. Hydrogen is inside the bracket with number 3 outside the bracket. So in total, we've got 3 atoms of hydrogen, each with atomic mass of 1. So in total, 3 for the hydrogen. And oxygen is inside the bracket with an outside number 3. So again, we've got 3 atoms of oxygen, all million 16 as a relative atomic mass. We then calculate the total atomic mass, so 27 plus 3 plus 48 is 78. So the total relative formula mass for aluminium hydroxide is 78. Question 18 says calculate the relative formula mass of PbCO3, lead carbonate. So the first thing we've got to do is calculate the mass of the lead. So lead has got atomic mass of 207. We've got 1 atom from the formula, so in total 207. Carbon, from the formula, we've got 1 atom, mass of 12, so in total 12. And oxygen, from the formula, we've got 3 atoms of oxygen times by 16, which is the atomic mass, so in total 48. We then calculate the total mass by adding all those numbers up, so 207 plus 12 plus 48 is a total of 267. So the relative formula mass of lead carbonate is 267. Hope you found this useful. Please subscribe, and I'll see you next time.